On one hand, variable is kind of a simple definition, right? It's simply a property or characteristic of objects that we measure. On the other hand, we already seen in the example with microwave phone that variables can actually have different nature. So let's talk a little bit more about that. Well, first of all, let me remind you how we define the variable. So variable is a property of individual which we measure or observe and which vary, for example, from one individual to another or for one individual in time. Of course, when I say individual, it means a lot of different things. It can be a physical object, phenomenon, process, reaction, run, and so on. So we will use this general word individual for all of those. But if you think about variables, how they represent it, how they measure it, and many other things, you can actually make this table like you see on this slide. First of all, variables can be separated into two big groups, which are qualitative variables and quantitative variables. So quantitative variable means it represents an amount. It's a quantity. While qualitative variable, it represents a quality or a category, because usually qualities are limited by a set of categories, by a set of levels. And then quantitative variables can also be divided to discrete and continuous. So you can think about quantitative variable, it's something that can be measured or can be represented with a number, and this number has a meaning, has a direct meaning. For example, 10 grams, you understand it's a 10 grams, so it's a certain amount of molecules. Every molecule has its own weight, and 10 grams, it's a total weight of this particular sample. So this 10 has a direct meaning. You can use this value for example, comparing different weights and so on and so forth. But even a quantity can be different. Continuous quantitative variable, it's a variable which, strictly speaking, has different outcomes. So if you measure weight with many decimals, for example, you use an analytical scale, then you can have a lot of different outcomes, right? So strictly speaking, the amount of outcomes you have is infinite, it's almost infinite. So in this case, we are talking about continuous values. So usually continuous values, it's the values which have at least one decimal. And then often you also have discrete values. And usually discrete values are either counts or it's a measured values where number of outcomes is limited. So let me give you an example. Every time you measure, for example, temperature, height, weight, and pH, you have some, if you use a precise measurement device, then you have some decimals, and usually you can treat these values as continuous, right? But for example, if you count like number of children in a family, or number of books which a particular scientist or scientists from a particular university publish, that's the number of values in this case is limited, right? You cannot have 2.5 children. It's always a whole number. It cannot be negative. It cannot be a very large number. Usually we have like 2, 3, maybe 4 children in a family. And that's what we call a discrete variable. Then if you talk about qualitative variables, you also have two subgroups, ordinal and non-ordinal. Ordinal means you can order the categories. So the categories have some relationship. While non-ordinal, it's where categories have no relationship. Again, an example, let's say age as a category. You can think about these categories like infant, child, teenager, young man, average age man, and so on and so forth. So in this case, we have categories, we don't have numbers, but we can order them because we know that infant is younger than child, child is younger than teenager, and so on. You can also think about length as a category, for example, like long or short, right? So in this case, you have also categories, but they are apparently they can be ordered because long is longer than short, it's bigger than short, right? The non-ordinal variables, it means that you cannot order them. For example, gender or biological sex, like male and female, you cannot order it because you don't have a possibility to define that one should be like larger or smaller or somehow else different from the other one, right? Color, color, strictly speaking, can be ordered, right? Because you have rainbow, you have the spectrum, and so on and so forth. But if you think about different shades of color, like for example, pink, or maybe salmon color, or maybe olive color. So in this case, it's difficult to order it. Very often it's difficult to order it, and the full color as observation can also be considered as non-ordinal variable. And then finally, there is also dummy variable, which is a way to represent a qualitative variable with numbers. For example, if you have like, let's say, sex, biological sex, males and females, So in this case, you can define 0, for example, for male and 1 for female, and that will be a dummy variable, which helps you to represent the qualitative variables in a numeric way. Okay. And then the same characteristic actually can be represented in most of these ways. Let's say we talk about body temperature. If you measure body temperature with at least 1 decimal, you can treat this value as continuous. Although, strictly speaking, it's not continuous, still number of values is limited, but somehow continuous. You can also think about 2 decimals or 3 decimals. That's even better. If you measure body temperature as a whole number, it's a discrete, apparently, value. Then if you measure body temperature using categories, for example, when you think about, I don't know, influenza, then usually doctors, they use these categories like normal temperature, subfebrile, and fever. And that's the categorical way to measure the temperature, right? So these are categories. Apparently, they are ordinal, so you cannot have a temperature which is non-ordinal in this case. But you can also use dummy variable. For example, you can see that we have 3 different categories. You can have, for every category, you can have 1 dummy variable. So for example, if temperature is normal, a particular dummy variable will be 1. If it's not normal, meaning subfebrile or fever, it will be 0. And the same for the other 2. Usually you don't need as many dummy variables as many categories. You need always by 1 less, because if you have all zeros, let's say you have normal, not normal, and not subfebrile, apparently it will be a fever. Another important set of terms which we need to consider comes from experiments. So when you run an experiment, you also use variables, but you use them in different ways. Usually that's the typical experimental run. You set experimental conditions, then you run the experiment, and then you measure the result of this experiment, right? From this point of view, you can again consider this simple experiment of making popcorn, and this is how it looks like, right? You have a microwave oven, and then you have some conditions which, for example, you want to optimize, but these conditions you can set manually. So it's not something that you observe. It's something that you define. For example, you can define time, you can define power, and you can define amount of salt to add to the final product, right? So these are all variables because you vary them, but it's you who define them. Then you have some fixed conditions, which in theory you can vary, but in this particular experiment you don't. For example, popcorn brand, you use the same brand, or maybe microwave oven brand, or operator skills if it's the same person who actually prepared the popcorn. Then you can also measure the something, right? So you can measure the outcome of this experiment. In this case, for example, you can measure taste, or you can measure or observe a color of the popcorn. So you can see in all these cases, we have different properties. The conditions which we optimize and the measured values are variables, so they vary. And the conditions we are fixed, it's also a property of your experiment, but they are not vary. They do not vary, right? So they are fixed. So you can see a lot of new definitions are needed. So let me define this. So first of all, the variable that you vary manually, we will call this a factor. So it comes from Latin word factor, meaning who which acts, right? So if you change something manually, we will call it a factor. And then factor can be controllable. It's when you indeed intentionally change it, but it also kind of uncontrollable factors. For example, if you have a temperature, room temperature, it's uncontrollable factor if you cannot change it, but it still can potentially influence your experiment, right? Then the outcomes of your experiments, the properties that you measure at the end, at the final product, which you cannot change directly, that's what we call a response. So we kind of believe that these variables, they respond to the changes of the experimental conditions. So that's why we call them response. They vary mostly randomly, but also they depend on the experimental conditions. And that's why we call them response. Okay. So this is kind of a general picture. You can see a process or reaction as a gray rectangle in the middle. And then you can see the blue characteristics, temperature, time, pH, and concentration. It's the controllable factors. Experimental skills and reaction properties are also controllable factors, but you fix them. And then product yield and product purity, for example, it's the response. Right? We also sometimes use a specific term for factors. factors are independent variables. So independent means you change them independently of each other. You define the factors, while the responses are dependent variables because the value depend on the factors. Right? And now it's kind of a picture that summarizes everything. Imagine that I would like to find out best conditions of a chemical reaction. And what I do here, you can see I have 5 different conditions. It's operator, reactor, I have temperature, I have pressure of the reaction, and I have a catalyst. It's the first 5 columns here. You can see that the first 2 columns are gray because, as you see, they are not variables. They do not vary. They are fixed. And then the next 3 are blue. It's the variables. So this is the conditions that I change manually. The last 2 variables, they also vary. It's a response, right? It's the outcome of the experiment that I ran with this or ran with these conditions. And this is what I measure. So this is indirectly. They change indirectly. So these are all definitions that I have that we have so far. The rows are runs. So we have a sample of 8 different individual runs. Sample size is 8. The last 2 columns are responses. The first 5 columns are controllable factors. So these are factors that can potentially influence the experiments. And then the blue and the red columns are variables. The first 2 are not variables because we do not change them. They do not vary. So the temperature, it's a discrete variable. You can see that it has only 2 different levels. It's 100 or 200 degrees. The pressure is also a discrete variable. It also has only 2. And then the catalyst is a categorical variable, so it's a qualitative. We don't have numbers here, it's a quality, it's a type of catalyst, right? Then yield, it's a continuous variable, and the purity is also a continuous variable. The 3 variables that we change manually, we call them independent, and the 3 variables that reacts on this change, potentially react on this change, and then we measure them indirectly, they will call dependent variables because we believe that they depend on the experimental conditions that we set. So this picture kind of gives you an overview over all important definitions about the variables that we have. And now let's talk about the other 2 important definitions. It's a sample and population.